So we've talked about how the course works, how things are graded, and how you would study for the course. Let's talk about what's actually in the course just for a minute. Now, there were three major things that we want you to get out of this course. Uh, we want you to be able to critique, explain, and draw evidence-based conclusions from chemical data. That's kind of an ambitious goal. Um, but you'll at least have the beginnings of that and understand what is involved in it. You're going to interpret data that we give you, and you're going to do it verbally, say what the data means, graphically, draw a graph to depict relationships, and you'll be able to write symbolic equations that show what's going on, chemical equations, mathematical equations. We're also going to look for patterns in the data, and we're going to use those patterns to make explanations and draw conclusions. And we're going to see that when people say I'm experimenting, what they're really doing is testing a hypothesis, a tentative guess about how things work. We're going to see how you establish relationships between variables. And we're going to look at the way people abuse data sometimes. This is very important. People will cherry pick data. They'll only select data that supports the conclusion that they've already decided is true. And they'll make misleading graphical presentations as well. Second, we're going to look at chemical problem solving. You're going to plan and execute strategies for solving common problems in chemistry. And the techniques that you learn here will go far beyond just this course. Some of these techniques are going to do you a lot of good no matter what your field is going to be. So there's something broader that you can take out of this course besides chemistry. You're going to be able to, for example, check algebraic results by tracing units through the calculation. So you'll have confidence that you did the algebra right when you have a mathematical problem. We're going to see how to check calculated results by using multiple strategies for finding a solution. And we're going to estimate results when you have ambiguous or incomplete data. You're going to learn how to correctly report results in a way that clearly emphasizes how the results are uncertain. You have to consider uncertainty in results before you can make decisions based on them. And you're going to see a little bit about how to check and critique results of problems as well. And finally, we're going to look at how nature works. We're going to look at several natural phenomena and some technological innovations and see how they work. You're going to use chemical concepts to explain or connect natural phenomena or understand, the basic principles behind a phenomena or a technology. For example, we'll see why things have color and how an MRI machine operates. Essential to that, we're going to be connecting large-scale macroscopic behavior with events on the atomic or molecular scale. For example, we'll connect energy that's released or absorbed from a reaction by the making and breaking of chemical bonds between atoms. You're going to be able to connect basic material properties that materials have with molecular properties. For example, you'll be able to connect the polarity of a molecule, whether it has a positive end and a negative end, with what kind of things can dissolve in a fluid made of that molecule. You'll see why salt won't dissolve in gasoline, but alcohol will dissolve in gasoline. I'd like to know in the question at the end of the lesson what you want to get out of the course. And I'll read these pretty carefully and I'll try to tie those in. with these other major themes that we have going on.